The course of human history is shaped by our power for creation. We imagine and then build. We analyze and then improve. We explore and then use our discoveries to change the world. From the Stone Age to today, our shared past is a story of determined dreamers, rallying the people around them to create solutions to problems great and small. Seco is a part of that story. Our tale begins with the light bulb. Everyone knows Edison's famous invention, but few remember the rapid advancements that followed its introduction in the late 1800s. Among these was a shift from carbon filaments to ones made of tungsten. A metal with the highest melting point of any element, tungsten allowed light bulbs to burn brighter and longer than they ever had before. In the 1920s, the General Electric Company used relatively massive amounts of tungsten in its production of light bulbs. A substantial portion of the material was designated as scrap due to its being either too clean or too dirty for use in filaments. A GE scientist by the name of Samuel Hoyt discovered a remarkable use for this scrap. By combining it with specific portions of carbon and cobalt at high temperatures, a unique material was created. At the time, cemented tungsten carbide was considered second only to diamond in terms of hardness. This new material could cut steel, cast iron, wood, and even glass far more effectively than anything that had come before. Realizing the significance of his discovery, Dr. Hoyt convinced GE to establish a new company under the name he gave his creation, Carbaloy. While the potential for the new material was high, the early years proved immensely challenging. Carbaloy, which was what cemented carbide came to be called, was hard enough to efficiently cut metal, but was also extremely brittle. Machinists at the time were hesitant to adopt it for fear it would easily shatter if dropped. Enter a Detroit legend. Henry Ford was determined to pay his workers more than the competition could afford, but doing so required finding a way to boost production levels. His search for higher productivity brought him to cemented carbide. Incorporation of the material in metal cutting applications yielded tremendous results. Parts that previously took over 2 hours to make could be finished in less than 30 minutes. With the Ford Motor Company as a massive customer, Carbaloy's early success was assured. The Great Depression soon followed, and while Carbaloy suffered along with the rest of the nation, the company survived. As America emerged from one of its darkest periods, Carbaloy introduced a new concept for industrial education. The company fitted a Model T panel truck with a small lathe and hit the road, visiting manufacturers to teach them about the application of its products and boosting productivity for companies across the country. When America entered the Second World War, cemented carbide proved an invaluable asset. Our company's product, coupled with American production systems, allowed tanks, jeeps, planes, and guns to be manufactured at rates that were previously unimaginable, shifting the tide of the war. In addition to being used for production, it was discovered that cemented carbide had incredibly high compressive strength, leading to it being used in armor-piercing shell cores. The Allies made use of these American-made munitions throughout the war, most dramatically when taking the Cherbourg Peninsula in France. After several failed attempts to break enemy lines at the town of Saint-Lô, Allies employed armor-piercing shells against the enemy, eliminating dozens of Tiger tanks in a single afternoon and leading to the capture of Cherbourg. The economic boom following the war's end saw incredible demand for commercial goods. With cemented carbide established as a fundamental part of American manufacturing, Carbaloy proceeded to further improve the technology through the introduction of chip breakers. Traditionally, as cemented carbide cut metal, it produced long, razor-sharp pieces of metal known as chips. By altering the geometry at the tip of the cemented carbide, Carbaloy substantially altered the process, resulting in much smaller chips and much less risk of injury to workers. The company continued its history of innovation in the 1950s, working with GE to develop a process for subjecting graphite powder to over 1.5 million pounds of pressure at temperatures over 5,000 degrees. The result? Man-made diamond, a material that enabled many of the breakthroughs in the technologies of the past 6 decades. The advancement of cemented carbide continued at a brisk pace. Traditionally, the material had been brazed to steel tool holders then ground to an edge. The introduction of carbide inserts eliminated this highly time-consuming process and simplified use by manufacturers. Titanium carbide coatings were introduced in 1970, followed by aluminum oxide coatings in 1973, both boosting efficiency. Parts could now be cut at 1/10 the time it took Henry Ford when he first adopted cemented carbide. Carbolloy's breakthroughs encompassed more than just cutting tools, though. Cemented carbide balls and ballpoint pens, kitchen knife sharpeners, line guide rings for fishing poles, uranium fuel pellets, nose cones for rockets, and dental drills. The factory on 8 Mile Road developed inventions that changed our world in great and subtle ways. Despite its tradition of excellence, the company found itself struggling in the 1980s. GE began using Carbolloy as a training ground for upwardly mobile managers, and investment in the company faded. While still a leader in cemented carbide inserts for turning applications, low market share in milling and drilling applications held the company back. Then, in 1987, things took a turn for the better. Seco, a Swedish cutting tool company, purchased Carbolloy in 1987. A producer of cemented carbide tools since 1932, Seco had spent the 70s and 80s investing heavily in research and development to become a world leader in cutting tools. With the acquisition of Carbolloy and several other key technology companies, Seco expanded its portfolio and capabilities substantially. Over the following decades, Seco introduced products that set new standards in the industry in terms of their ability to increase manufacturers' output while reducing their costs. Product lines such as Mini Master replaceable tip-end mills, Turbo Mill indexable cutters, and Perfomax drills redefined productivity and became staples within the metal cutting industry. Then, in 2006, Seco introduced Duratomic, a revolutionary process involving manipulating oxygen and aluminum at the atomic level. Creating an entirely new type of coating for carbide inserts, Seco once again raised the bar for metal cutting processes. In 2008, Seco moved from its long-standing headquarters on 8 Mile Road to a new state-of-the-art facility in Troy. In 2014, a new production facility was added to provide custom tools to manufacturers across North America. While the look of the company has evolved, those who work here embody the same traits of those who started the journey nearly a century ago: a passion for discovery and dedication to improving manufacturers' processes.